so on our last assignment, 8.4, we did the angle triangle similarity. Today we're going to do two new triangle similarities. We're going to have side similarity, which is our SSS, and then we're going to have side angle side. And we're going to take 10 minutes today, and we're just going to talk about those two theorems and do some examples of each of those today. So looking at the side similarity, you have to set up a fraction or a ratio for each of the different sides. So as you can tell, AB is to RS. So this side right here is to that side right there. Then we go BC is to ST. So BC would be to ST. And then we can go AC is to RT, the outsides. So you just have to match up the proportions, and then you set them up as fractions and simplify them. If they are equal, notice right here, if they are equal, then the triangles are similar by side theorem. Okay? So here's an example right here, and they color-coded these for us to make life a little bit easy. But we just look at this, we go 8 over 6 equals the green, 12 over 9, equals the blue, which is 16 over 12. And notice everything on top comes from this triangle right here, and everything on the bottom in the denominators comes from this triangle over here. When you simplify all these all simplify to 4/3. Those ratios, and when they simplify and they're equal, then these two triangles would be similar. Okay. And we're trying to check which one is similar to ABC. So we can tell that this one is. We're just going to set this one up just so you can see the difference between the two. So if I take this triangle ABC again and I go 8 and 12 and 16, 8 was red, so I would go 8 over 8, 12 over 10, and 16 over 16. And we can tell just by looking at these two both equal 1. This one doesn't equal 1, it's 1.2. So these are not equal. So these triangles would not be similar. Okay. And that's how you could indicate that. All right. Looking at that, knowing that these two triangles are similar, and all we have is side lengths, then we can set up a proportion to help us solve for x. I know that AB is similar to DE, so AB is similar to DE. So I have 4 over 12 is going to be equal to, I'm going to use BC. You could also use this side, but BC we know is to EF, so it's going to be to 18. Okay? And then to solve this, you've been solving these for a while now. You cross multiply. So I have 12 times x minus 1 equals 4 times 18. 4 times 18 is 72. Then I distribute here. 12x minus 12. I add 12. And I get 12x equals 84. I divide by 12. And x equals 7. Okay. Now, I could have used AC and DF, so I could have went 4 over 12 equals 8 over 3 times x plus 1, and solved it the same way. I should have come up with the same answer. This one to me just looked easier, so that's why we used that one, but it doesn't really matter. Whichever one you'd like to use, you can use. Okay. Here they want you, says, which of the 3 triangles are similar? And then they want you to write a similarity statement. A similarity statement is writing like triangle ABC is similar to triangle whatever, DEF or whatever. In this case, we're going to check, we're going to set up 2 proportions and just check these and see if they are congruent. So, or see if they are similar, not congruent, similar. So I'm going to take, and on top, I'm going to put these 3 sides of this triangle. So I'm going to put them in order of shortest to largest. So 20, 24, and 26. Okay. And then I'm going to take this triangle, I'm going to put them in the same order, smallest to largest, so 24, 30, and 33. And we're just trying to see if these proportions are equal. And when you do that, you can take 20 and put it over 24. Put it in your calculator, and you see that that's 0.83. And then you can take 24 and divide it by 30. And that is 0.8. And 26 divided by 33 is 0.78. So you can see that those two triangles are not similar because these ratios or these proportions are not similar or equal. Okay? So let's check and see if LMN is similar to XYZ. So we're going to set up another proportion here. I'm going to use the same order. I'm going to go 20, 24, and 26 from this triangle right here. And then we're going to go to this triangle here. My smallest is 30. The next size is 36. And the next size is 39. And we're going to check that and see 20 divided by 30 is 0.66. This one is also 0.66, and that one is also 0.66. So those are similar. So my triangles in order is important. So I'm going to say triangle LMN is similar to triangle. Now I have to match this up. LM is which side? LM is the shortest side. Okay. So then I look at the shortest side over here, which is 30. So then I'm going to go, and L is close, the included angle of the largest and the smallest. So I go, so instead of going Z, I went largest to smallest here. So it's going to be Y, Z, X. No, that's not right. It's Z, Z, Y, X. Sorry about that. So that's your similarity statement for these two triangles, this triangle here and this triangle here being similar. Okay. And that would be similar by, you probably should include by side, side, side. The other theorem today is the side angle side. So we have two angles, and those angles are called the included angles. And those are the angles that are in between the sides that we're checking if they're proportionate. So just like on the last one, we have two sides here that are proportionate, and then we have two angles that are congruent. So ZX would have to be proportionate to PM, and then the angles are congruent, and then YX is to NM. And you'd set that up, and if you have the proportionates and the angles that are congruent, then you have the two triangles that are similar. So to this point, you have angle, angle, you have side, 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 and you have side, angle, side similarity. And we're going to do some examples with the side, angle, side right now. So looking at this, they have a tent here. We have our included angle in this case, which is, they are both the same. So the angles are congruent. We just need to check the sides to see if they're proportionate. So we're going to go 6s to 9 as 10 is to 15. And we can see that those are both 2/3. So those are equal. So these two triangles are congruent by side, angle, side. And we can set up a similarity statement. Triangle GFH is similar to triangle BAC by side, angle, side. Okay? So that's just an example, pretty good example where we have the included angles and the sides that are proportionate. So the triangles are similar by side, angle, side. Let's look at this right here. It says explain how to show that the indicated triangles are similar. So we have right angles here, and we have included sides, so we just need to check. SR has to be similar to PN. So SR is 24, PN is 18. RT, which is 28, has to be to NQ, which is 21. We check that. We know the angles are congruent, so then we check that. 24 over 18 is 1.3, and 28 over 21 is also 1.3. So I know that those are equal. So these two triangles are similar by side angle side. Okay. Let's check this one right here. Now this one's a little bit tricky because you think you would take and you say, well, they both share 12 here. You have to be really careful. You have to match these up. So we have XZ is to YZ. So XZ is 12 and YZ is 9. So we're going to go 12 is to 9 as ZW is to ZX. So ZW is 16 and ZX is 12. We have a right angle here, and we have also a right angle here. So it's just the orientation is just a little bit different. Okay? So 12 over 9 is 4 over 3. 16 over 12 is also 4 over 3. So those two triangles are also similar by side angle side. Okay? I hope that helps. We'll have your assignment on big ideas today. Hopefully the quiz went well for you yesterday. If you have any questions, please reach out to Ms. Rollins or I. Thank you.
Okay, I just don't know where it's saved to. Kurt, yeah.
As long as you didn't delete, no, I'm just
I didn't delete it. I
I'm
told it
just
to
kidding.
save. I just don't know where it's saved.
I think we click on this button right up here.